It's a huge temple. Bredishwar, that's big temple. In local language, they call it the big temple. It's more than 200 feet tall. The cupola on top is 70 tons. It weighs 70 tons. The seat sits on is the platform is 200 tons, and all this sits on the huge gopuram, which is covered with beautiful sculpture. The gopuram has been designed to bear that kind of weight, and it has been doing that for the last 1,000 years. It was built by one of the Chol kings. I think it was Rajendra Chola, in around 1000 BCE. I mean CE. During this 1100 years, it has withstood 4 major earthquakes, and nothing has happened to it. Incidentally, such a huge monument has no foundation. We must remember that many times we are told that our ancestors were not in the habit of writing. That is not true. They were prolific writers, and they left behind a very large number of treatises on a large number of subjects in the form of copies of copies of copies of copies. That was another thing they used to do. There was no printing at that time, so they used to handwrite copies. Mostly the students in various universities and gurukuls and centers of education used to do that. Now, I'm just mentioning a few examples of them. The 4 Veds, of course, everybody knows about the Ved and the Upanishad, the Puran and the Upapuran. What are not very commonly known are perhaps the 6 Vedanga. These were written to help people understand the Veds better. Everybody knows that the number 0 was invented by India. But what is not commonly known, even in India, even among Indians, is that number system, the place value system, and the method of mathematical operations, they were all invented by India. And this has been accepted, recognized, and mentioned and written down by several non-Indian scholars, going as far back as 900 CE and up to 1800 CE. They were Arabs, Persians, Italian, and French scholars who have recorded this. Ancient Indian knowledge of medicine, surgery, and veterinary science. Now, we have discussed it partly, but I would like to quickly mention that Sushrut Samhita, Acharya Sushrut has described 300 types of surgeries that he carried out, cataract surgery being one of them. 125 surgical instruments that he had designed, and the etiology of as many as 1100 ailments. The etiology is how a disease takes place, what causes it, and how it is to be treated, and so on. 1100, as many as that. Sushrut Samhita, of course, is recognized as the father of surgery. Those of you who have been to Melbourne, the Royal College of Surgery, there is a statue of Acharya Sushrut, and says the father of surgery.
Namaste and welcome to all the viewers that have joined us today. I welcome you to another episode of Indic Talks. I am Ojasvi Mishra, and today we will be discussing the large body of evidence for the width, depth, and accuracy of ancient Indian knowledge systems. Our distant ancestors, several millennia ago, had deep and accurate knowledge of a very large number of subjects such as astronomy, mathematics, medicine, metallurgy, meteorology, philosophy, civil engineering, architecture, and sculpture, etc. There exists a very large body of evidence of their knowledge. And to elucidate the same, we have our speaker today, Prakash Chitre, who is an independent researcher and author. He acquired his postgraduate qualifications from IIM Calcutta. He has authored the book Our Intellectual Heritage, which was published by Motilal Banarsidass Publishing House in March 2024. I welcome you, sir. Thank you so much for gracing our platform, and I request you to take over from here.
Namaste. Thank you very much. I would like to thank you, Ms. Mishra. I would like to thank the Center for Indic Studies of the Indus University for inviting me to make a presentation. And whosoever is going to watch this video in future, I would like to thank them for, being interested enough to take part.
Yes.
So this is what I'm going to present. now is from sort of an extract of my book, Our Intellectual Heritage. Their objective, which was, as Ms. Mishra said just now, it was published by Motilal Banarsidass quite recently in February, March 2024. As the title says, it is our intellectual heritage. It's not history, it's a history of it's our past. The objective of my research is to share the awareness of the kind of knowledge our ancestors had. And when I say, I'm sorry, when I say ancestors, I don't mean just ancestors 100 or 200 years back, but several thousand years back. And what is interesting, and which again is very, very important, that it is not knowing that such a knowledge existed, but knowing that there exists a very large body of evidence for the ancient Indian knowledge. And this body of evidence is for the width, depth, and accuracy of ancient Indian knowledge. And this is what we're going to discuss now. In my research, I found that, as I said, the large body, which I was able to divide it into 12 different groups, or categorize it into 12 different groups of evidence. These are the first 6, the ancient archaeological findings and so on and so forth. Another 6, there are 12 of them. You can have a look at it naturally, but you need not, because I'm going to discuss each and every one of them and give you examples of those that evidence. Now, let's begin with the ancient archaeological findings, because these are perhaps the oldest, among the oldest. These findings were made from various parts of India, but mainly from what is still known as Harappan civilization or the Indus Valley civilization. That nomenclature is inadequate today, because at the time when Harappa was discovered in 1921, and Mohenjo-daro in 1922 by Mr. R.D. Banerjee. At that time, these are the only 2 sites known to about our past, known to mankind. And both of them, Harappa was in the basin of Ravi River, which is a tributary of Indus, and Mohenjo-daro is in the basin of Indus River. So these were called the Indus Valley civilization. But subsequently, it was found that, in later years, over the last 100 years, I would say, many, many more sites have been discovered. There are about 2,000 of them. About 500 of them are in Pakistan, and 1,500 are there in India. And a large majority of them are in the basin of the river Saraswati. So it would be more appropriate to call it the Saraswati Sindhu civilization rather than the Harappan civilization or the Indus Valley civilization. Now, what do we find? I mean, in terms of the intellect of our ancestors, what do we find in this? See, there's a wide range of subjects which it covers. First is, I would like to mention metrology. See, as much as, by the way, the oldest site discovered so far is Birana, which has been carbon dated to 9,500 years. And next to that is Rakhigarhi, it's about 8,500 years. Rakhigarhi, incidentally, is the largest SSC civilization site discovered so far. Now, in these sites and all other sites, the Indus Valley civilization or the Saraswati Sindhu civilization was a very, very large region. Balochistan and Sindh and Western Punjab in Pakistan, and our Punjab, Haryana, Eastern UP, and Rajasthan and Gujarat in our it was such a huge region. So what is interesting is that even in this huge region, they found that the bricks, by the way, even 6,000 years back, they used bricks to build all their structures, including their houses. The bricks were in a standard ratio of 1:2:4. That is, 1 is the height, 2 is the width, and 4 is the length. That was the ratio. That is not the exact size as such. There were some sites which had a ratio of 1:2:3, and some others which had 1:2:2. But a majority of them were in the ratio of 1:2:4. Incidentally, this ratio is known as the most efficient one for effective bonding. Besides this, the integral ratios of their structures, all their structures, whether it was the boundary wall or the length and the breadth of the stadium, or the water bodies, the reservoirs, the houses in the lower town, middle town, and the upper town, they were all in integral ratios. There was no there's no fractions. For example, let us say, give me one or two examples, by 4:8, or 5:19, or 5:9, all integers. In fact, the site at Dholavira in Gujarat went one step further. The ratios were in cubes and squares, like 4:9 or 4:16. And that makes it very interesting, considering it is all, Dholavira was about 5,000 years back. Now, another thing they knew about was weights and measures. They were known to use weights and measures for different kinds of objects that they were selling. They were traders, by the way, in a very big way. They made graded weights for small items. There were small measures. Did it go? Small measures for small items, like say valuable items, like say silver, gold, or the precious stones. And there were larger, heavier weights for, say, the food grains and things like that. They were all in decimals. The graded weights were all in decimals, multiples of decimals. They were not odd numbers. Not even multiples of 5 and multiples of 10, all of them, full decimals. And at Lothal, they found ivory scale, and at Kalibangan, a terracotta scale. What is interesting is that in both cases, the measures were common. They were gradations of different lengths. The minimum length, like we have, say, centimeter or millimeter on our scales, they had the lowest scale measure was 1.76 average millimeters, and it was perfect. Every single division was precisely 1.76. That's the average, because I say average because in Kalibangan it was 1.77, and in Lothal it was 1.75. That's very, very, very close to each other. Then small scale geometry. They had knowledge of small scale geometry, which is seen on the floor tiles, designs on the floor tiles, and micro designs on the pottery, like space fillers. These designs were perfect segments of perfect circles. That means they knew how to draw a small circle, a perfect circle, not an approximate circle. Then town planning, their layouts with well-planned grids of roads and structures. Incidentally, most cases, the main roads, were in the north-south direction, orientation. Civil engineering, well-planned networks of drainage systems, town level as well as home level. Water management, interconnected water reservoirs. See, not all of them. See, Kalibangan, sorry, not Kalibangan, Mohenjo-daro and Harappa, they were in water, there are plenty of water there, but in areas like Dholavira and to some extent even Lothal, there was not enough water, so they had to preserve water. So they had also made arrangements for rainwater harvesting. From the castle, from the upper layer, the water would flow down, come down to the house level drain, and from there it would go to the reservoirs. Every house, please note, every house had a bathroom and a channel for wastewater egress to go out. After going out, it would meet there was a sump, so that if any precious metal had dropped down, or jewelry, that could go down, and it would then join the main drainage system of the town. So they had this town planning, civil engineering, water management, and sanitation. That's extremely important for a healthy town. Another example group is the ancient temples and cave monuments. Our temples, especially those that still survive in the south, they are excellent examples of beauty, examples of civil engineering, examples of architecture, examples of sculpture, and so on. Let's take sculpture first. The magnificent temples in the south and the Kailashnath temple in Ellora. But I'm sure many of you know, the Kailashnath temple in Ellora is a huge temple, and it was made with a top-down approach. The hillside, the entire rock hillside was carved, beginning with the top and going all the way down, making beautiful sculptures on the way, and the interior also. Obviously, there's no, in this kind of a sculpture, there is no margin for error, and no errors were made. The south architect, the magnificent temple, the south, like Halebedu, Hoysaleశ్వర temple in Halebedu, and Brihadishwara in Tanjavur in Tamil Nadu. In my opinion, Brihadishwara temple ought to be rated as one of the man-made wonders of the world. It's a huge temple. Brihadishwara, that's big temple. They local language, they call it the big temple. It's more than 200 feet tall. The cupola on top is 70 tons. It weighs 70 tons. The seat sits on is the platform is 200 tons, and all this sits on the huge gopuram, which is covered with beautiful sculpture. The gopuram has been designed to bear that kind of weight, and it has been doing that for the last 1,000 years. It was built by one of the Chol kings. I think it was Rajendra Chola in around 1000 BCE. I mean CE. During this 1100 years, it has withstood 4 major earthquakes, and nothing has happened to it. Incidentally, such a huge monument has no foundation. It is standing there without a foundation. Paintings, the beautiful paintings in Ellora, which are more than 2,200 years old, and acoustics. Yeah, this is an extremely important example. The knowledge of physics. There are as many as 25, exactly 25 or 26 temples in Tamil Nadu, Karnataka, Telangana, and Andhra Pradesh, which have musical pillars. These are made from the granite rock that have been carved out. Let me explain. For example, let me explain. The most well-known one is the one at Hampi. There is, let's say, one pillar. There are 8 pillars, main pillars. Each pillar is surrounded by a set of 7 sub-pillars. Now, the main pillar represents some instrument or the other, musical instrument, say sitar, or ghanta, or ghatak, and so on. All the 7 pillars around that pillar, let's say we're talking about the one that represents sitar. All the 7 pillars around it, they represent different notes of sitar. So if you knock on them, they emanate a sound of a note of sitar. Like this, there are, as I said, 25 temples. Meenakshi temple is one of them. Then what is extremely important thing to note, that the oldest of those temples was made in the 5th century CE, and the most recent in the 15th century CE. So about a span of 1,000 years. And they were in 4 different states. So they were separated from each other by space and time. Obviously, it was not a chance happening. Our engineers, they knew what they were doing and what they had to achieve. And that's why they were able to replicate it. This is extremely important from the scientific point of view, that they were able to replicate what they were doing, and they continue to do it for 1,000 years. This also means that there must have been a good amount of documentation. Without that, so simply from word of mouth, from one generation to other, from one place to another, I personally don't think it's very likely. There must have been documentation, and a lot of treatises, books, etc., have been destroyed. Maybe many, of course, millions have survived, but maybe one day we'll find out. Metallurgy, corrosion resistance beams on the other Konark temple. The Konark temple that we see, of course, it is magnificent. But next to it was a bigger temple, which collapsed about 500, 600 years back. The girders consisted of massive iron beams. They're so big. Each one of them weighed something like 5 to 7 tons. And length could be around more than 23 feet. There is very little corrosion on them. Now, they were as girders. They were not meant to be exposed to atmosphere. Konark being on the coast for 500 years, they have been exposed to saline atmosphere, and yet they are intact, because had it not been corrosion resistant. By now, they would have, in 500 or 600 years, they would have so badly rusted, the whole thing would have crumbled and you couldn't have recognized them as beams. So they were corrosion resistant. There are other examples of corrosion resistance technology we'll discuss later. Now, we must remember that many times we are told that our ancestors were not in the habit of writing. That is not true. They were prolific writers, and they left behind a very large number of treatises on a large number of subjects in the form of copies of copies of copies of copies. That was another thing they used to do. There was no printing at that time. So they used to handwrite copies. Mostly the students in various universities and gurukuls and centers of education used to do that. Now, I'm just mentioning a few examples of them. The four Veds, of course, everybody knows about the Ved and the Upanishad, the Puran and the Upapuran. What are not very commonly known are perhaps the six Vedang. These were written to help people understand the Veds better. Each one had a different function. Let us say one of them was the Nirukta Vedang, which dealt with how a particular word was formed, what is the Vyutpatti, what is the origin of that word. Then Vyakaran Vedang was Vyakaran, grammar. Then Chand Vedang, which dealt with meters. So there's six Vedangs were there. And Surya Siddhant was a very, very complex treatise on complex astronomy. There have been several updates to this particular treatise. The most recent one was in the 5th century CE. But some of the older updates were made as far back as 7,500 years ago. That is 5,500 BCE. Shatpat Brahman again deals with astronomy, and it was written about 5,000 years ago. Vedang Jyotish, again astronomy and astrology, nearly 4,000 years back. Chandravakya astronomy was written by Vararuchi Katyayan. He worked out the longitudes of the moon and expressed them, because these are long formulae and he used the Katapayadi system to write it down, so that it's a shlok and then all the numbers can be read. Aryabhatya, Brahmasphat Siddhanta was in astronomy, and Khandakadyak by maths. Both of them were by Brahmagupt. Many of these wrote a number of treatises. I'm mentioning only the main ones, that the most popular ones by which they are known. The Panchasiddhantika, Brihad Samhita, Siddharth Shiromani, Sushruta Samhita, I think most of us have heard of. That is about the medicine, written by Acharya Shushrut. It was written 5,000 years back. The Western world would like us to believe that it was written only 2,500 years back, but that is not so. On the basis of the astronomical observations made in Shatpat Brahman, it is very clear that Shatpat Brahman and Sushruta Samhita were written 5,000 years ago. We can perhaps discuss it later. Shalihotra Samhita is on veterinary science. Everybody knows that the number 0 was invented by India. But what is not commonly known, even in India, even among Indians, is that number system, the place value system, and the method of mathematical operations, they were all invented by India. And this has been accepted, recognized, and mentioned and written down by several non-Indian scholars, going as far back as 900 CE and up to 1800 CE. They were Arabs, Persians, Italian, and French scholars who have recorded this. The number system, place value system, and more than 2,000 years back. One example of that, okay, we'll come to that later, where we see one example of that. The Bodhayan theorem triples, what we have been told as the Bodhayan, also discovered them in his own time, but Bodhayan, about 250 years before Pythagoras, he worked out the formula a square plus b square is equal to c square in a right angle triangle. Bodhayan also computed the value of infinite values, infinite of square root 2. He computed up to 5 correct decimal places. And 2 is a non-square number, so there is no finite value for square root 2. It goes into an infinite series of numbers. He worked out up to 5 decimal places. He also worked out the 7 triples. Triples are, in this context, are the sides of a right angle triangle where all sides are in integers. So the first triple is 3, 4, 5. 3 is the height, the perpendicular, 4 is the base, and 5 is the hypotenuse. He worked out 7 of them, the first 7. And by the way, he lived in the 8th century BCE. Now, nature's golden rule was first observed by Pingala that, say, the nautilus shell or certain flowers or even the branches on the trees or the leaves, the lines on the leaves, they had a certain ratio. Like the ratio was 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. That is, in the sequence, each number was equal to the sum of the 2 previous numbers. Now, this is very commonly prevalent in nature. This was first observed by Pingal in the 6th century BCE. It was codified by Virahanka in the 6th century CE and Gopal, as well also by Gopal and Hemachandra in 11 CE. It is commonly known as Fibonacci sequence, who lived in the 12th, 13th century CE. He was an Italian, and he didn't try to claim that it was his discovery, but still the Western world would like to believe that it was his discovery. He didn't claim it. The Bakshali square root of Bakshali manuscripts were discovered in the western part of India, northwestern part of India, now in Pakistan, at the end of the 19th century. It had 2 prominent things in it. One was the method for calculating the square root of a non-square number. And remember, non-square number doesn't have a finite square root value. It goes into an infinite series. But as long as you can, but there was a method. And it's been found that this method by Indian scholars, by this method was an average method found by Newton about 2000 years later. Another discovery was the zero number 0 was used as a number in its own right and not as a placeholder. The infinite series of Madhava Sangamgram, the 14th, he was a brilliant scholar from Kerala. He did so many things, but one of the things that I'm mentioning here is the infinite series of the sine function. About 250 years later, Newton and Leibniz also are supposed to have discovered this, whatever it may be, but Madhava did it much before, in the 14th century itself. India's metallurgical inventions and exports. India made about 4 metallurgical inventions. 2 of these brought in a lot of money for India. India was Sone ki Chidiya. That was one of the reasons. Was not. It was, of course, spices and silk made a contribution, but there was an industrial production also. Or woods, the superplastic. Uku is what the material is called in the south, in I think Tamil Nadu or Andhra Pradesh. And uku there means the boiling or to boil. And this material, this steel is an alloy. It's a micro alloy, very, very minute constituents of various other elements like phosphorus and molybdenum and everything. It's a superplastic material because although it's a metal alloy, it has 2 properties which are not found anywhere in any metal or any alloy. That is, it was very hard as well as very ductile at the same time. As a result, it could be used to make very sharp edges. The Syrians developed an extremely good technology to make swords from this material. What is known as the dreaded Damascus swords and Damascus daggers were made from this. And this was definitely before the 4th century BCE, because when Alexander came down here, his biographer, Curius Curtius, I think, if I remember correctly, he wrote that when he came to India, the Indians presented him with 100 talents of a shining metal, and that metal was uku. The Greeks called it the wood steel. So that is about, say, 2000, at least 2,400 years back. The corrosion resistance technology, we talked about the temple at Konark, but there are also the iron pillars. The most famous of them is the one at Mehroli in Delhi. Then the other two are other three. One in Kodachadri in Karnataka. There's one in Dhar and one in Bhopal. These are also all corrosion resistant ones. Then delta phase heightened bronze. This is used for what is known as the speculum mirror. It is ideal for you to be used for as space telescopes, because there is the reflection is on the front surface, whereas ordinary glass, which has a bottom layer reflection surface, the refraction takes place when the light enters and again when the light exits. There is no such thing happening in the speculum mirror. The Bidri ware is also made from this. It's a very shiny. When it is polished, it makes very shining material. Hundreds of correct astronomical observations. See, ancient Indians were excellent observers of the sky, and they knew. One solid example is the nakshatra. They had divided the globe into so many 27 segments. There were 28 earlier. One dropped out because of the obliquity of the Earth's axis. You will find them observations in the Rig Veda. The Surya Siddhanta, of course, is an treatise on astronomy, very complex astronomy. Shatpat Brahman, Brahad Samhitas, Siddhant Shiromani of Bhaskaracharya II, and of course, Ramayana and Mahabharata. See, what is interesting is that these were not random observations. Take, for example, Surya Siddhanta, there were many updates made at different points of time. Now, take all the updates made during one given time as a folder. So all the observations within that folder representing that particular time, all of them were very congruent with each other. Had those been random observations, they would not have been, there was chances that they would not be congruent. So one position would indicate they were made 2,000 years back, another position of a star or a nakshatra would indicate it happened some 1,000 years back. That was not the case. So they were very, very congruent with each other, which means that these were real observations and they knowledgeable observations. Philosophy, ancient, flourished in India extremely well. There were 6 Vedic schools of philosophy and 4 non-Vedic schools of philosophy. Vedic schools were Sankhya, Vaisheshik, Mimamsa, Vedanta, Nyaya Sutra. Mimamsa is also known as the Purva Mimamsa. Vedanta is also known as the Uttar Mimamsa. The Vedanta, of course, there are 2 parts, Advait Vedanta and Dvait Vedanta. Within Advait Vedanta also, that's the most popular philosophy today. Now, besides these 6 Vedic schools, there were 4 non-Vedic schools, Buddhism, Jainism, Ajivak, and Charvak. Now, of these, as you know very well, Buddhism and Jainism developed so very well, they became religions. Ancient Indian knowledge of medicine, surgery, and veterinary science. Now, we have discussed it partly, but I would like to quickly mention that Sushrut Samhita, Acharya Sushrut has described 300 types of surgeries that he carried out, cataract surgery being one of them. 125 surgical instruments that he had designed, and the etiology of as many as 1,100 ailments. The etiology is how a disease takes place, what causes it, and how it is to be treated, and so on. 1,100, as many as that. Sushil Samhita, of course, is recognized as the father of surgery. Those of you who have been to Melbourne, the Royal College of Surgery, there is a statue of Acharya Sushrut, and says the father of surgery. But the only thing is that they would like us to believe that he flourished about 2,500 years back. Now, as we discussed earlier, it was exactly about 5,000 years back. Agnivesh Tantra, Charak, there was a scholar of Ayurveda. His name was Acharya Sushta. Whatever. It will come back to me in a minute. He had 6 disciples, students. All six of them were so bright that each one of them went on to Acharya Punarvasu Atreya, by the way. His six students went on to write a Samhita of their own. Agnivesh was the brightest of them all, and he was the first one to come out with the Samhita. Now, Agnivesh Tantra later on came to be known as Charak Samhita because Agnivesh had written it, but Charak went on to codify it properly. And he acknowledged at each chapter here, in each chapter, he's acknowledged that it was written by Agnivesh, and I'm only codifying it. And it contained 12,000 verses in eight chapters. Ashtadhyayi was in 8 chapters. Agnivesh Charak Samhita is in 8 chapters. Bhel Samhita, Bhel, Harit, and others, they were all students of Atreya. Ashtang Hriday in the 11th century, Vagbhat, I'm told that Ashtang Hriday is taught to the first year students of Ayurveda before they go on to progress to, because it is the simplest of them all, before they progress to the other Samhitas. Shalihotra Samhita, Veterinary Science, also has 12,000 verses and 8 chapters. Ancient Indian knowledge of linguistics, etymology, and grammar of Sanskrit. Created by brilliant minds. These were brilliant minds. We all know, everybody knows about Panini, who lived around the 5th century BCE. He wrote his Ashtadhyayi, which is also known as the Vyakaran Vedang. It helps you understand the Ved better. About 200 years before him flourished Yaskacharya, who wrote Nirukta, and that Nirukta came to be known as the Nirukta Vedang. And he also wrote a Nighantu. Nighantu is about very, very difficult Sanskrit words, and he has discussed those words, how they came about, what they mean, etc. Vartikakar Katyayan, Vartika of Ashtadhyayi, and Patanjali Mahabhashya. See, the Vartika of Ashtadhyayi is a commentary on Panini's Ashtadhyayi. Even Patanjali's Mahabhashya is a commentary on Panini's Ashtadhyayi. So you can understand the greatness of Panini's Ashtadhyayi. There are two great minds wrote commentaries on them to help people understand it better. One very important thing about Panini's Ashtadhyayi is that he worked out 4,000 sutra with which he built the Sanskrit language and the grammar of Sanskrit language. I have been told by many computer scientists that the 4,000 sutra are like algebraic formulae, as precise as that, and which can be, therefore, the language, the Sanskrit language is an ideal one for writing computer programs. I must forgive my age. I sometimes tend to forget a little and then become incoherent. The thousands of manuscripts of ancient Indian texts found outside India. Many, many thousands of ancient Indian treatises were found outside India. A very large number of them in Tibet. And also, like Bakshali manuscripts, we said, where it was discovered in what is now in Western Pakistan. Now, Europe has more than 1 lakh of these manuscripts. More than 30,000 are there in UK alone, a similar number in France, Italy, and Germany. These are primary countries where these manuscripts are there. These are on various subjects like mathematics, Bakshali manuscripts that we discussed just now, but mentioned the zero and base R of Bakshali square root of non-square numbers, astronomy, Siamese manuscripts. Now, these were discovered in Siam, Thailand, and they came into the hands of the French envoy over there, and he took it back to France with him. This was around the 16th century, yes. They remained in the Royal Library for quite some time. Then they were translated from Sanskrit into French, and they came to the hands of the very, very well-known French astronomer Jean-Dominique Cassini. He was an Italian to Bobby on, but he settled in France, so his name was Frenchified. These manuscripts, they astounded Cassini by the extent of their knowledge they showed, the depth of the knowledge they showed. And he said that they're far superior to the Greek astronomy and at par with our current knowledge of European astronomy. Mind you, this is in spite of the fact that the Sam's manuscripts are only the Karana type. They're neither Tantra nor the Siddhant. A Siddhant is a really high, like Surya Siddhant is a very high level astronomy. Lower than that is the Tantra, and at the bottom is the Karana type. Karana type was used by, say, a village with astronomer or astrologer. He has to work out important dates for. He's not concerned with the complex astronomical calculations and mathematics, and yet it astounded Cassini. Medicine, the Bauer documents. The Bauer documents were discovered in the late 19th century on the Silk Route in Xinjiang. They came into the hands of, when they were given to, his name was Hernley. Hernley was a German, brilliant German, an Indologist, and working for the Asiatic Society of Calcutta. He translated them and published a document in the early 1905 or 1910. These are on medicine. Then there were two ones that I would like to mention. Drepung, where they are there in the University of Beijing, and they are on Buddhist philosophy. Spitzer documents are in Germany, again on Buddhist philosophy. These are very old. As I said, Bakshani manuscripts itself were more than 2,200 years old. The centuries-old writings of non-Indian scholars about the Indian knowledge. See, India was highly knowledgeable, and this fact was known to people outside India, very far away. See, they were Chinese, they were Persians, they were Arabs, they were French, they were Italian. The Chinese, Huensang, everybody in India remembers and knows about Huensang and respects Huensang. And another one was Yijing. Both of them came to India in the 7th century CE. Of course, they didn't come together. They were both of them separated from each other by about 70 or 80 years. Huensang spent 5 years in Nalanda, and Yijing lived there, studied there for 10 years. Both of them took back very large quantities of manuscripts with them, which they were permitted to do. In fact, it is Huensang who is mentioned in his writings that there were 10,000 students in Nalanda at that point of time, and 2,000 teachers. Persians, Al-Khwarizmi, after whom the word algorithm has been designed, and Al-Biruni, they're both Persians. Al-Khwarizmi lived in the 9th century. Al-Biruni lived in the 11th or 12th century. Al-Biruni visited India several times, and he wrote as many as 27 books, texts on India, Indian society, Indian culture, Indian knowledge of science, Indian knowledge of mathematics. He was a brilliant man. He was a great mathematician also. He's mentioned, he by the way is mentioned that the Indians followed their own kind of method of calculation, their symbol system. That is what he was talking about, the number systems and methods of calculation operation invented by India. Italian, Leonardo Piccolo Pisano, which is better known as Fibonacci. He wrote a book called Liber Abaci, There's Liberation from Abacus. And in it, there is an important chapter, very important chapter called Modus Indorum, which means the Indian method. There he has mentioned the Indian method of the number system, the place value system, and the mathematical operations. French, Jean-Dominique Cassini, I just mentioned just now. Pierre Sylvain Laplace lived in the 18th, 19th century, and he was considered as the French Newton. In his writings, he said it very clearly that the number system, place value system, etc., were a mathematical invention by India. Yes, I forgot to mention the Arabs, the Muhammad al-Fazri. He translated the Brahmaswar Siddhant and Khandakhatyak of Brahmagupt. They lived in the 8th century CE. Sayyid al-Andalusi was a polymath. He lived in the 11th century. He was a Moor, and he wrote a book called Kitab Tabakat Ulamam, which means the book of the categories of nations, where he had categorized various nations in Europe, Arab region, and Arabia and India and everything. And he had categorized them, he had graded them, and he said very clearly in the book that India is the most scientific nation in the world. Now, it is important to be noted that he didn't just say most mathematical nation. He said the most scientific nation. And in the book, he has acknowledged, besides mathematics, he's acknowledged various branches of science where India was so very well advanced. Then Al-Idrisi was an Arab who lived in, I don't remember, but during the Crusades. And he's the one who has he wrote that there is no match to Hindu steel, which is used for the Damascus daggers and the sword, Damascus sword. He was talking about the Uku steel. The ancient Indian universities discovered so far, there are 15 universities, ancient universities have been discovered so far, and they have been excavated and being studied. The oldest of them was in Takshashila. It's the most famous university. It was founded sometime either in the 6th century BCE or 8th century BCE, and it flourished till the 5th century CE, so about 1100 to 1300 years. Sharda Peeth is now in the present-day Pak-occupied Kashmir. Nalanda, everybody knows about it, but also famous ones were Vikramshila, Telhara, Udantapuri, Kanthalur, Nagar. Kanthalur was in Kerala, Nagarjunakonda in Andhra Pradesh, and Nalanda, Vikramshila, Telhara, Udantapuri, etc. were in the Magad and Bengal area. Vallabhi was there in Gujarat. So their universities were there all over the country. Then there were the important centers of education. Magad, Kashi, Kusumpara, by the way, is part of Patliputra, this present-day Patna. Ujjaini had a famous observatory. It came into existence at least in the 4th century CE. Mysuru, Kanchi, Kanyakumbh, Kashmir, and Kerala. Now, out of these, at least 3 universities, Takshashila, Nalanda, and Kanthalur, taught more than 60 subjects, 64 subjects to be precise. And out of these 3, 2, that is Takshashila and Nalanda, had, there is documentary evidence that they had 10,000 students, 10,000 plus students, and 2,000 plus teachers. What I would, at the end of this, what I would like to say that the ancient Indian knowledge was not confined to any point of time or subject or geography or a limited number of scholars. This is extremely broad, which is very significant. It was very widespread. Let's take first the subject spread. I have written about only 19 subjects. In my book, I have written about only 19 subjects that India had knowledge of. But there were many, many, many that I couldn't even think of writing about. There are so many of them. What is significant is that, as we saw earlier, Takshashila, Nalanda, and Kanthalur taught 60 plus subjects. You can imagine the width of knowledge, the width of content that existed at that time. It was huge. Then scholars. In my book, I have written about only 72 scholars. And they were from all over. And I'm absolutely certain that I have missed out many scholars whose works are known, whose names are known, and I have missed them. It's perfectly possible. That happens in research. But what is important is that there were other scholars whose works are known, but the authors are not known. Like, for example, the Surya Siddhanta. It's not known who wrote the Surya Siddhanta. And the scholars who designed the townships in the Harappan civilization or the Saraswati Sindhu civilization, the builders obviously had knowledge of metrology. They had knowledge of civil engineering. They had knowledge of sanitation. They were brilliant minds, but their names are not known. So in terms of, and then they spread all over. Again, all over the country. Now, I'm sorry. The third is the time spread. Now, when we go back in time, we have discussed the knowledge of metrology in the Harappan civilization, which is more than 6,000 years old. But then there are indications of a harbor off the coast of Tamil Nadu of Pumpuhar. And the remote sensing scientists, geological remote sensing scientists believe, with the further research is yet to be done, that they have reasons to believe that it was an ancient port with proper channels, broad channels for bigger ships and small channels for smaller ships. And they believe that maybe as old as 13,000 years. And that means those engineers of Tamil Nadu, they had the brilliant ones, they had knowledge of civil engineering, port building, and shipbuilding so long ago. geographic spread. Now, all these people, all the sites, all the scholars, they were from all over the country, north, east, south, west, spread all over the country. So that is our legacy. That is our heritage. Uh, yes. Now we talked about the spread. It was also very deep and accurate. It has been discussed in various parts in my book. That is how deep was the knowledge, how accurate it was. So we can all be very proud of it. Again, this is just, I would like you to see that while there is tremendous width to the ancient Indian knowledge, my book touches only the following areas. You can have a look at it. Etymology, grammar, metrology, weights and measures. We discussed all of them. Geography, knowledge of the Barnsthamba and so the Somnath temple is an example of the knowledge of geography. That from that point up to the South Pole, there is no piece of land, and that has been examined by scholars. They found it to have been correct. Metaphysics, there were scientists, people who are metaphysicists, like Umaswati was a metaphysicist. Economics and political science, of course, we know Kautilya was an expert on these subjects. Now, my book has is based on the primary research done by a very large number of scholars, more than 220 scholars, in fact. And a majority of them are from India, but many others are from 14 other countries to the west and east of India. Between them, they represent something like 45 different fields of scholarship. I examined their research papers published in professional journals, the articles, their lectures, their books, and my research is that resulted in my book, Our Intellectual Heritage. Please permit me to repeat this, and I'm very, very keen that this should be noted, that we Indians, irrespective of our background, such as ethnic, etc., have every right to be very proud of very ancient civilization and the knowledge, because it is based on valid and verifiable facts, and which I have presented in my book, and not flights of fancy or wishful thinking. And another important thing, I have presented it without any disrespect to any other civilization. This is what we were, and this is what should be known to all of us. Thank you for your patience. Any questions?
Thank you very much, sir. It was extremely insightful. Now we will enter into the question answer session. And my very first question actually comes about who exactly would be understood as the pioneer of astronomy, because scholars like Dr. Elst argue that astronomy's origins originally are Greek, and the word Kendra, for example, is comes from a Greek word, and it is actually astrology that may be pioneered by India based off of the basics of astronomy in the Greek civilization. And I believe that that requires some clarification from your end, if you could.
Okay. Now, I suppose you're talking about Dr. Conrad Ernst. Yeah.
Yes.
Okay. Now, I have discussed this point in my book. I have tried to look at it from 4 points of view. One is the depth. The second is width. The third is antiquity. And the fourth is accuracy. On all 4 grounds, I'm sorry, I don't like to make comparisons, but all 4 grounds, Indian astronomy is far superior to, ancient Indian astronomy is far superior to the Greek astronomy. For example, the oldest book on the Greek astronomy is Almagest. I think I don't know how it is pronounced, but Almagest by Ptolemy, which is around 2,500 years back. But as we discussed just now, Surya Siddhanta, some of those the updates made are 7,500 years old, and they talk about the coordinates of the sun 7,500 years back, much older than the Greek astronomy. The width, as the astrophysicist Dr. Anil Narayanan says, the Greek astronomy is based on only a small number of books, whereas in India, there were very, very large number of treatises which are written on astronomy. We saw some of them, like Surya Siddhant, Shatpat Brahman, Vedang Jyotish, and so on. Brahmasput Siddhant. Now, at least Surya Siddhant is far older, far, far, far older than any of the Greek books. Accuracy, I gave that example of what Jean-Dominique Cassini, the French astronomer, he said about the Siamese manuscripts. Although these were just the Karana type, not Tantra, not Siddhant. And he said very clearly, I mean, that's been mentioned, it's been quoted in my book. He said very clearly that this is far superior to the Greek astronomy. So with due respect, I would like to disagree with Dr. Ernst, Conrad Ernst.
Sir, another question is, like, for example, there are so many temples in the south where you can see solidified mercury lingas being prayed to. And solidification of mercury is something that has been found by Western science to still be something that requires development. But here we have temples that are already doing that. So, my observation from that is that while we do have a lot of theoretical science, which is yet to be credited globally, but at least it is found by researchers like yourself. But why is there a lack of scientific tools being found when we are actually looking for them? Like the tools that were used, like for example, there was a news piece that came out that something akin to a battery was found in Egypt. But we know that battery was something that has been written in Rasayan Sanhita by Agastya, where he also mentions electrolysis. But we never usually talk about scientific tools being found in India, or those particular devices being made in India back in the time. So could you clarify that as well?
Okay, now you see what happens. I mean, I cannot answer your question fully, but I can try to answer it partly. See, take the Kailashnath temple, for example. It's a magnificent example of sculpture and knowledge of meteorology. But you don't find where the wasted the chips of rocks were. They've not found the tools. Now, where are they? They must be somewhere because we see the result. Similarly, the huge petroglyphs of Ratnagiri, they are there. There are more than 1,200 of those petroglyphs in Ratnagiri and the neighborhood of Ratnagiri. They don't know the tools, what the tools were, where the tools were, and those have been approximately tentatively carbon dated to 12,000 years, 10 to 10,000 years, 12,000 years. Similarly, let's take the example of the knowledge of acoustics. Their knowledge of acoustics was not incidental. It was not a solitary example. There are 25 temples. That's a large number where they have been able to replicate it. So the knowledge was there. But what is the science behind it? We don't know. We don't have the documents. But does not mean that the documents did not exist. Or the tools for Kailashnath, the tools for the so many other things not exist. They exist, but only we have not found them. See, what happens has happened, unfortunately, in our case, texts were destroyed. Now, I want to go into who destroyed them and for what reason, etc., etc. I don't want to go into that. But the fact remains that they were destroyed. And we don't know which ones destroyed and some of those that were destroyed may have contained that knowledge or the descriptions. Besides the ones that were destroyed, there are millions and millions of manuscripts still surviving in India, in the various centers of various organization institutions like the Oriental Research Institutes in Pune, Mysore, and Kerala and Tamil Nadu, Rajasthan, Madhya Pradesh. They have a large number of manuscripts. Then there are other Oriental Research Institutes in Chennai, in Delhi also. They have manuscripts. Now, somebody has to translate this manuscript. A very major scholar, Mr. Vivek Dabroy, was doing that translation. And he was working diligently on that Unfortunately, he passed away a few months back. I wish there were many, many Vivek de Broys in our country. I'm sure there are. There are. I don't know their names, but there must be. So over a period of time, I'm sure if there is a concerted effort made to find out what the documents are, what they mean, what the details they contain, uh, we may find out. Let me give you one more example about Bodhayan and the evidence that he worked out the formula a squared plus b squared is equal to c squared. I recall in my book I have mentioned some several scholars there, but one particularly I remember one Professor Dr. David Henderson. He was a mathematician of Cornell University, and he passed away, by the way, a few years back in a road accident. He had come down to Kanchipuram, and where he was allowed access to the Kanchipuram manuscripts. And that is where he found the evidence. And he said it very clearly, he's very categorical in stating that this very clearly shows that Bodhayan worked out the formula of a squared plus b squared is equal to c squared in a right angle triangle. Then there are a lot of manuscripts in Kerala. One famous mathematician and maths historian, K.V. Sarma, has examined many of the documents, Sanskrit and Malayalam, in which belong to the Kerala School of Astronomy and Mathematics, founded by Madhav Sangamgram, and he has done a splendid job and he's highly respected. He also no longer lives. I mean, he passed away several years back. So that is what it is. I'm sure I know I'm not answered your question fully, but at least partly yes was I have.
So I think another question is that you had mentioned this briefly in your monologue as well. You talked about how oftentimes we are discredited in our techniques of archiving. We're often told that we were an oral tradition, we never passed on things with writing and everything. But I'm pretty sure that a civilization can't last as long as we did with no archiving. So, what were the archiving techniques that were used back in the time?
Archiving techniques, all I can say is that, look, the universities were one excellent repositories of knowledge. Millions and millions of manuscripts existed at least in Nalanda and Takshashila. In Nalanda, the manuscripts were, they said that when it was set on fire, the fire lasted for 3 months or 6 months. And it is not unlikely. I mean, again, in my book, I tried to look at, how there could have been millions of manuscripts. Now, I have tried to look at it from 5 points of view. One is the need. Firstly, where was the need to have so many manuscripts? Number two, where is the manpower? See, there were 10,000 students, and most of the students studied there. It took them 7 to 8 years to do super specialization or post graduation. So the time was there, the manpower was there, the content. The Indians were prolific writers, and the knowledge spread was so much. We looked at it just now. The storage space was there. So all these things existed. So it is believable. And Nguyen Sang has also mentioned it. So all these things say that there were billions of manuscripts. So how can we say that Indians were not? It was only oral tradition. The oral tradition came later, or the oral tradition existed very long ago, but at least not for the last 5,000 years. There are copies of Sushruta Samhita, which is 5,000 years old, or copies of Shatpat Brahman, which is again 5,000 years old. So it is, it can't be said that the Indians were not in the habit of writing. All knowledge was not just passed on.
So, like I said, oral tradition often has been extended a lot of disdain because it has been it is incorrectly been used synonymously with rote learning, and oral traditions had its own techniques of learning our
It's
scriptures
gone again.
verbatim, right? Um, so, one of the questions that comes to my mind is that this would be a very suitable segue into understanding what did the ancient Indian pedagogy look like, especially things like assessments. What did admissions look like? What did institutions of education look like back in the time?
Pedagogy, I can't go much into details on that. And see, firstly, let me come back to it. I do not mean to denigrate oral traditions and the habit of knowing things by heart, the learning. It was part of the process of learning, but that did not replace writing. The writing was there, and that's why so many manuscripts existed. About the process of admissions, I found that in the bigger universities like Takshashila and Nalanda, uh, there were many, although there were as many as 10,000 students, the the rate of admission was only 1 out of 3 applicants. Only 1 out of 3 applicants gained admission in either Takshashila or Nalanda. Now, this speaks a lot about India's thirst for knowledge, India's thirst for knowledge. Imagine so many 100 years back, how difficult and how arduous and how dangerous the journey must have been, going all the way to Takshila or going all the way to Nalanda. And when they went there, they didn't know whether they would get admission. So they knew the chances were that they would have to come back the same way, going through the same difficult journey. Even then, they went there, the students went there. That shows their thirst for knowledge. And I like to think, and I hope I'm right, that the ancient Indians were really, really, very hungry for knowledge. And not knowledge for the sake of money, but knowledge for the sake of knowledge. And incidentally, these manuscripts and the knowledge, they were all free. The students didn't have to pay any fee. The local king or the townspeople, they took care of all the expenses, and the students also paid for their with what is known as the assistantship now. So that's that.
Sir, I would like you to expand on your findings about Indian knowledge systems in relation to economics and political science.
I'm afraid I can't expand much on that. I'm not go into the depth on that part. I left it unattended or partly attended because main exponent of that was Kautilya, and everybody knows about Kautilya. So I thought it was not necessary to go into his books on economics and other things, political science. But I have mentioned that in passing.
So one of my questions is that it seems to me that very soon Indian knowledge systems being acknowledged for their accuracy, as you mentioned, through the kind of work that you're doing and many scholars like yourself are doing, could be a thing of the near future. And so when that does happen, how do you think that institutionalization in India would change? Because right now, if you look at it, the scientific core fields are very underpaid. And oftentimes, Indians are told that we are better at executing innovative ideas rather than coming up with better innovation. But that seems to be quite antagonistic to the findings that you have brought to the fore. So, how will institutionalization be refashioned once there is holistic acknowledgement of the fact that ancient Indian knowledge systems are a reflection of how we are innovative, how we are inventive, and how we have been pioneers in a lot of Indian sciences?
Yeah. See, for example, I mean, you're absolutely right. The last sentence, the Indian IQ shows how innovative we were. We made metallurgical inventions. We made inventions in mathematics. So these are all original works. So how can it be said that the Indian mind is not innovative? That I would say even for today, it's a false allegation. Indian mind is extremely innovative, and it's not for nothing that Indians are respected all over the world, especially in the Western seminal work in innovation. So uh, I would like to disagree with the but I don't think people commonly think that on those lines these days. They understand that look, Indians are something special. Now, I'm sorry, I'm being very um, but I am proud of being an Indian.
So actually, that's precisely my point. Like oftentimes when this appreciation is coming about how Indians have this indispensable role in playing, to play in corporations and innovative ideas that are being played out in the West, it is said that they are more effective in roles where you have to execute an idea than actually ideate. So this is something that a lot of statistics and a lot of
Yeah, again, we're coming back to the
recruitment
point.
bias is there. That you will always see Indians being put at positions of execution rather than ideation.
I don't think that people at the very senior positions in, say, the IT world or technologies, they are just executors. They are brilliant minds, they're innovators, and they have made important contributions in original ideas. Now, I'm afraid I don't know, I don't remember the names of many of them, but they are there. And they would not have risen to such top levels only on the basis of their ability to manage. There's also the ability of their intrinsic value of their being knowledgeable or being innovators of knowledge, the initiators of knowledge, and not just executors. See, a
So,
lot of unfair things are said about us
Mhm.
by Indians and non-Indians. And okay, let's just take it with a pinch of salt.
You are right, sir. However, my question also is that how will, like a lot of Indian institutions are actually being run on the Western model. Clearly, our models are more functional and our models have stood the test of time. So once there is complete acknowledgement that Indian knowledge systems work, how will the institutions that are going to take these projects forward refashion themselves and restructure themselves from the very core?
I'm sorry, I don't think I'm qualified to say that because I'm not an educationist. I'm only a poor researcher and author. So I cannot answer that question. But I do hope that, yes, I heard from many educationists that our system was a good system where, the students started learning at a very, very early stage. There were temples. Most major villages in India had a temple. In the temple, there were two people, mainly the two people. One was the pujari. He was never the Brahmin, never a Brahmin, mostly a Vanvasi normally. And the other was the Brahmin. And it was the puja was done by the pujari, not by the Brahmin. The Brahmin's job was to teach all the children in the village, irrespective of their backgrounds. Now, whether they were Brahmins, Kshatriya, Vaishya, whatever they were, he taught them all, and he was supported by the entire village, all the town, the village people. After that, they went to the Gurukul, and there were lakhs of Gurukul in India. From the Gurukul, then they went into either the universities or to centers of education. So this system worked because as you can say that even in a very difficult environment, there were 10,000 students at any given time, most of the given times in Takshashila and Nalanda. It worked. It worked because the Indians came up with a lot of original ideas, original thoughts, and they invented things. And mind you, the inventions were not confined to only the highly educated people. Even say, for example, the Kodachadri pillar was made by the Adivasis of that region in Karnataka to welcome Adi Shankaracharya in the 8th century. Now, those they were not the kinds who went to the center of education to study or to the university, but they had the knowledge. And it was probably based on the initial knowledge they got from the village temples or whatever. But as I said, I'm not the right person to answer your question because I'm not an educationist.
So, like,
Yeah, ji.
let's say, for example, that I think you have some very glowing qualifications, like being a pass out from IIM Calcutta, and I think that has led you to a lot of places. So, in your opinion, what are some of the core issues in those kind of institutionalizations that could be remedied in the way that we've used to function? Meaning that I think one of the things that has been taken up in IIM is that towards the end of one's semesters, they are taught management from the teachings of Srimad Bhagavad Gita. So I think that is a great way to restructure and reintroduce something that is both new and old. So, like from, or maybe let's say parenting for an example. What would parenting look like from an Indian purview? So, I think those things are very important for us to think, and your book helps us think in that direction. So, I would thank you for your insights and the wonderful book, Our Intellectual Heritage, that really enriches one's, like you said, pride in our civilization, and also understanding the antiquity of the pioneering studies that we've had. I would like you to conclude the session, sir.
Thank you. Thank you very much. As I would say, I can only repeat what I said. Let us all be, all of us have the right, regardless of which part of the country we are from, what is our ethnic background. I would even say whatever, and any other kind of background, we have a right to be very, very proud of our ancestors, men and women. Remember, it's not only the men. It was always, there were women like um, Ubhaya Bharati. Ubhaya Bharati is an excellent example of how a woman could be a scholar and could be accepted as a scholar. May I say
Yes,
something
please,
about that?
please, please
Yeah.
do.
Now, there was a famous debate between Mandan Mishra and Adi Shankaracharya. Mandan Mishra was a follower of Purva Mimamsa, and Adi Shankara was the follower of Uttar Mimamsa, that is Vedanta. And later on, developed into the Advait Vedanta. Uh, uh, Adi Shankara went all over India, and in his travels, he came to a place where, wherever Mandan Mishra was, and Mandan Mishra was highly regarded as a very, very knowledgeable person, very intelligent in the field of Purva Mimamsa. Adi Shankar wanted to have a debate with him. So he went to him and said that let's have a debate. Let's discuss. You you talk about Mimamsa. I talk about Vedant. And let us discuss and decide. Now, that was the way our minds worked those days. There was no fighting to decide who was better. There were debates, at least the scholars, between the scholars, that was so. So they decided to have a debate. A date was fixed. And of course, there had to be a judge. Now, Mandan Mishra's wife, Ubhaya Bharati, was highly knowledgeable herself. So, Mandan Mishra asked, since Adi Shankaracharya was so young, he asked Adi Shankaracharya to decide whom he wanted as the judge. Now, Adi Shankaracharya had heard about Ubhaya Bharati, and he said, okay, let her be the judge. And the debate lasted for several weeks. There were scholars from all over areas who came and watched. They sat through the debate. And in the end, the bet was that, look, whoever wins, the other one, the loser, will follow his way of thinking. At the end, Ubhaya Bharati summarized mind you, she had the ability, she was so brilliant, she had the knowledge, and she had the ability to summarize the debate, and she gave a decision that the winner is Adi Shankaracharya. Now, this incident itself says a lot of things, which again I have discussed in my book. One thing is that it was recognized that a woman could be knowledgeable. Another thing that was the woman could be extremely intelligent. Third, woman was not considered as inferior to man. Adi Shankaracharya, he opted for her to be the judge. Now, mind you, he opted her to be the judge for his own knowledge, his knowledge, and the knowledge of Mandan Mishra. Thirdly, the debate was attended by a very large number of scholars from all over. They came and attended it, which means that they accepted the fact that a woman was the judge. So sometimes it is said that the Indian society was very, very male-centric and women were not. I totally disagree with that. Women were highly, highly respected in the ancient Indian society. I'm not talking about what the situation may be today or yesterday. I'm concerned only with the ancient past, and that's what I've written about. Of course, in the universities, the women were not there because these were all residential universities. So naturally, they were not there. But in the centers of education, like Varanasi, the women, the Kashi, women were taught Sanskrit. In Kanthalur, There were medical, in the medical school, there were women. And by the way, the women students of Kanthalur were given special rations, extra rations of ghee and milk and everything. How can we say that the women were not respected and that the women were not educated? They were educated. Maitreyi, Gargi, one of them, I don't remember this Maitreyi or Gargi, she used to have a debate with Yagyavalkya in the Sabha. She had the courage, she was permitted to do that. So there are examples which very clearly tell us that, look, women were educated. Women were, another example, the Nagarjun Konda University. There are inscriptions showing the list and names of the donors. Many of them, remember, I repeat, many of them were women donors, which meant what? The women had control over their finances, that they could decide to give a donation. They had given the donation. It's not that the donation was given in their names. No, they were the donors. So all along, you see that women were educated, women were intelligent, women were accepted as intelligent and educated people, and women had financial control on their lives. I'm sorry, I instead of concluding and went on into further this thing.
No, but thankfully for that, actually, because we would have actually missed out on a lot of facts that you have presented right now. Thank you very much, sir. We hope to have many such talks with you. It's been extremely enriching. Namaste.
Thank you personally. Thank also the Center of Indic Studies of Indus University. Thank you very much.